Okay, on the next two stoichiometry problems, we're going to have an extra step added to these problems, and I'll explain why in just a second. But first, remember the first major step in all stoichiometry problems is starting off with a balanced equation. In this reaction, we have glucose reacting with oxygen to produce carbon dioxide and water. I'm hoping you remember from biology class that this is the equation or the reaction for cellular respiration. So to balance this equation, let's look at the glucose first. I see 6 carbons, so I'm going to jump over to my product side and change the coefficient before the carbon dioxide to 6. I am then going to look at the hydrogen. I have 12 hydrogens on the reactant side, so I'm going to jump over to the product side. I have H2, so to bring that up to 12 on the product side, I need to change this coefficient to a 6. Then finally with the oxygen, I have 12 oxygen here, plus another 6 oxygen with the waters. I have 6 over here on my reactant side for the glucose. So to bring up and account for the additional 12 oxygen, I need to change this coefficient to 6. That makes it a total of 12 plus 6 oxygens on the reactant side and 12 plus 6 oxygens on the product side. So this is the understood 1 in front of the glucose, and I now have a balanced equation. Okay, now let's look at the problem. It says the combustion of glucose is an energy source for the human body. Calculate the number of moles of oxygen needed to oxidize 12.5 grams of glucose into carbon dioxide and water. Remember, out to the side, I always write what I'm starting with, which in this case is 12.5 grams of glucose, C6H12O6. And I am looking for moles of oxygen. Now in previous problems, the two that we did prior to this, I was going directly from moles of one substance to moles of another. And to do so, I used the coefficients in the balanced equation. This time, however, I'm starting with grams. So I can't go directly from grams of a substance to moles of another substance. That's not an even conversion factor. Okay? So I need to first go to grams of grams of glucose to moles of glucose, and then I can go from moles of glucose to moles of oxygen. Okay, let's write that out in our dimension analysis so we understand what we're doing here. Go ahead and start with the number that you are given. You will always start with the quantity of the substance that you're provided for in the question. In this case, that's 12.5 grams of glucose. Draw your horizontal line, draw your vertical line. Okay, now before I can go from moles to moles, I need to first go from grams of glucose to moles of glucose. Okay, you want grams of glucose down in the bottom. You want moles of glucose down at the top, or on the top. Okay, now to figure out what numbers go here, I need to use the formula weight. I need to figure out the mass, or how many grams of glucose is in 1 mole of glucose. To do that, I need to calculate formula weight, or maybe you call it molecular weight. But I need to go back to what I've learned previously and figure out how many grams of glucose is in 1 mole of glucose. I'm going to do that off to the side. So the atomic weight of carbon is 12.001. Hydrogen is 1.008. I'm getting these from the periodic table. I know you've done this before. And the mass of oxygen is 15.999. So to figure out the formula weight or the molecular weight, I'm going to multiply 12.001 times 6 because I have 6 carbons. I'm going to multiply 1.008 times 12 because I have 12 hydrogens. And I'm going to multiply the mass of an oxygen atom, 15.999, times 6 oxygens. Okay, all of those together added up will give me the mass of 1 mole of glucose. So if you do that, you should get to the number 180.156. 180.156 grams of glucose is the mass of 1 mole of glucose. So that is my conversion factor. Okay, just like before, that unit will cancel out. I'm now left with moles of glucose. That's not what I was looking for, so I'm going to keep going. I'm going to extend my horizontal line, draw another vertical line, put moles of glucose down at the bottom because I know I'm going to eventually want to cancel it out. And now I want to go on the top with moles of oxygen. I can go from a mole of one substance to a mole of another using the coefficients in the balanced equation. So let's look at the equation. It looks here that 1 mole of glucose needs to react with 6 moles of oxygen. 6 moles of oxygen. Okay? These units, once again, cancel out. I'm left with the unit of moles of oxygen. That's what I was looking for in my problem, so I can stop the dimensional analysis. If I multiply the top and divide by the bottom, I'll come to 75 divided by my denominator of 180.156. If I do that in the calculator, I'm going to mark it down here. I should end up with 0.16 moles of oxygen. That's my final unit. So my final answer is 0.416 moles of oxygen. So the only difference between this problem and the ones that we previously did, we were given moles of one substance and we simply went to moles of another. This one added the extra step at the beginning of going from grams of one substance to moles of that substance before going from moles of one substance to moles of the other. To go from grams of one substance to the moles of that substance, I use the formula weight or the molecular weight of that substance.